Hey guys, welcome back. This is Lei. In our previous tutorials, we have created multiple Conda environments for different analyses. The reason why we need independent Conda environments is that different analyses require different tools, which rely on different dependencies, or the same dependencies with different versions. For this reason, installing all the tools and dependencies in a single same environment almost guarantees conflicts. Creating isolated environments can solve this problem. However, here is a catch. Say you have spent tons of time and effort building a pipeline in a Conda environment, and now you have a new position. Are you going to rebuild your pipeline for a new position? Well, you can, but you don't have to. In this tutorial, I'm going to show you how to create a portable environment that you can carry with you anywhere you go. The traditional method for environment migration is to create a YAML file for your current Conda environment, which contains all the information of the tools and the dependencies you installed with Conda or pip, and then recreate this Conda environment with a YAML file on the new system. The limitation is that it only works for the tools and the dependencies installed by Conda. The tools you installed manually, or your customized scripts, or your data will not be included. Most importantly, this YAML file may not be compatible with your new system. That means you may not be able to recreate your Conda environment on the new system. A better way is to use Docker. With Docker, you can basically pack anything from your environment into a Docker image, including all the system libraries and dependencies, your Conda environment with all the packages, even your reference genomes and databases, or even your dataset, and your analysis scripts and customized tools. You can even pack the whole operating system in the Docker image. Basically, a Docker image is a lightweight virtual machine that you can carry with you. Advantages: it's portable and easy to share, and has version control, and it's even HPC compatible. That means you can build your pipeline on your laptop and use it on HPC. You can even download the pre-built pipelines in a Docker image from Docker Hub and directly use it on HPC. Now let's create a Docker image for the Homer environment we created for chipstick analysis. First step, activate the Homer environment. Create a Docker build directory. This is the directory we're going to use for the image building. Create a YAML file for the Conda environment. Copy everything you want to pack into the Docker image. You can also include your dataset if you want. Next, create a Dockerfile in the same directory. The Dockerfile is the instruction the Docker will use to recreate the Conda environment. Reinstall all the tools in the environment and pack all the data you specified in the Docker image. Note, this is the exact file name, so don't change it or add any extension, such as .txt. Now let's go through the content inside of the Docker file. First line, specify the Conda version we used on our old system. Labels, specify the information of the Docker image. Environment, specify the old environment and the new environment. Next, install all the Linux tools in our new Docker image file. Copy the YAML file to the new location in the image. Reinstall the Conda environment. Reinstall the Homer package. Copy the BW index file or the reference file to our new location in the Docker. As you can see, we put everything in the OPT directory. We can also copy our dataset we want to keep in the OPT directory. Make the new directory accessible and make it the working directory. The last part of the Docker file is optional. This part is to generate an environment activation script, just in case the Conda environment is not activated in the Docker image. This part is to generate an instruction script. You run it, it tells you what's inside of the image and how to access them. You can remove them and only keep the bottom part of the file. I have the whole Dockerfile on my website, so go ahead, download it, and change it based on your needs. I've left a link below in the description. Now we have everything, we're ready to build the Docker image. Go to the Docker build directory and run the following command. Docker requires administration access, so don't forget to use sudo. Give the Docker image a proper name. Once the Docker image is built, we can enter this virtual environment using the docker run command. IT here means we start an interactive session. Once we're in the environment, we can call the function to see if they are properly installed, which is the function that shows the location of this tool. If it tells you the tool does not exist, that means the Conda environment is not properly activated in the environment. So we can activate the environment manually using the environment activation script we created in the previous step. We can check the file system of this virtual environment in the Docker image using tree command. It shows the file system structure in the environment. As you can see, we install everything and copy all the files in the OPT directory. Because this virtual environment in the Docker image is isolated from the main system of our computer, to analyze the data stored on our main system, we have to connect virtual machine to the data folder on our main system. This step is called mounting. To mount the data directory, use -v followed by the directory on our main system and -w followed by the directory in the Docker image. Once mounted, we can analyze the data using the tools installed in the image. Docker images cannot be directly used on HPC because they require administration access. The workaround is to use Singularity. On your laptop, install Singularity and then convert the Docker image into a Singularity image, and then transfer the Singularity image to your HPC. On HPC, start an interactive session using the Singularity shell command with the new Singularity image. Mount the data directory using the bind option. The rest is the same. Activate the Conda environment if it's not already activated. Analyze the data using tools installed in the Singularity image. Now you have both Docker image and a Singularity image. You can carry them with you and use them anywhere you want without reinstalling anything. This is all I have for today's tutorial. Subscribe if you like it, and I will see you in the next video.